Okay, here are the notes for 9.6 on polar coordinates. We're going to start off by plotting some polar coordinates. I've placed a polar graph on here. You may want to pause the video and make a copy of this, or you can go online and print yourself out a copy. Just type in polar graphs. Okay? So, notice from the graph that it looks very similar to our unit circle, and it's got the same radians on there. But it's got all these extra rings. Each of those rings represents a radius. And so if I have a radius of 4, I'm going to count out 4 from my center. Okay, so let's plot the first one. My angle is 2 pi over 3. So my theta is 2 pi over 3. So if I go to 2 pi over 3, I am way over here. And now I'm just going to count out 5, because the 5 is my r. From my center. And if I count out 5, 1, 2, 3, 4, I'm right here. And that's where my point is. That's the point 5, 2 pi over 3. Now let's plot the next one. I'm going to use a different color. I'm going to use, let's use green. Okay. And again, my r equals -3. My theta is 11 pi over 6. So I'm going to go to 11 pi over 6. And that's way over here. If I count out -4, I would probably get right, I would move out 4 from there. However, if you remember, our radius can't be negative, so what we end up actually having to do is we have to shoot through the center of my graph back over to 4. And that actually gives me right here. So -4, 11 pi over 6 is actually plotted at 4, 5 pi over 6. So when you have that negative radius, you have to go back through the pole and plot the point over on the opposite side. Alright, let's move on to the next thing. Now the next thing is where we are going to look at finding other points that have the same value. Because the one thing about the polar graphs, if you read the beginning, each point, there's an infinite number of ways to write it, based upon how many times you go around the circle. So let's go to our next graph, and we're going to write 3 additional points for our radius of 2.1, and our theta is -5 pi over 4. Well, if I look where 5 pi over 4 is, or -5 pi over 4, that actually puts me back at right here, which is 3 pi over 4. So one of my first points I can write is 2.1, 3 pi over 4. Okay. Now, I can do one of two things. I can go around counterclockwise again, clockwise, or I can go counterclockwise. Doesn't matter. If I go counterclockwise, I'm going to add 2 pi to 3 pi over 4, and I end up at 11 pi. What am I doing? Okay. But what if I want a negative radius? Well, we're just going to kind of do the reverse of what we did in example 2. So this is where my point actually is. I'm going to shoot back through my pole to the opposite side, and that gives me 7 pi over 4. So that's going to be -2.1, 7 pi over 4. Okay, so there's my 3 additional points. And again, these aren't the only 3. There's an infinite amount depending upon how many rotations we are. That last one I just did, I could have done negative 2.1 comma negative pi over 4. Both of them would be correct. Alright, so now let's move on to example 4. Example 4, we are going to convert now from polar to rectangular. Rectangular is the name for the type of graphs we've been doing. That's the normal XY. And the thing to remember is this, that my x value is r times the cosine of theta, and my y value is r times the sine of theta. So in this point where my r is equal to 6 and my theta is equal to negative 4 pi over 3, all I'm going to have to do is substitute those in to find my x and my y. And a lot of times what I like to do is I actually just like to make a coordinate system or coordinate points and just put them in there. The r cosine theta and the r sine theta. And now just substitute. My radius is 6 times the cosine of negative 4 pi over 3, comma, 6 times the sine of negative 4 pi over 3. Well, the cosine of negative 4 pi over 3 is, my brain just went blank, it would be negative root 3 over 2. The sine of, oh, it's not. What am I doing? I'm looking at the wrong point. That's never a good thing. Sorry about that. Should be negative 1/2. Caught myself. Okay. Then do the same. 6 times the sine of negative 4 pi over 3 is positive root 3 over 2. Multiply the two together, and my points, my final point is negative 3, comma, 3 root 3. So this is the rectangular points for that polar points that I started with. Okay, let's do the same for the next one. My r is now root 7, so I'm going to go root 7 times the cosine of pi over 2 and root 7 times the sine of pi over 2. Well, the cosine of pi over 2 is 0, so 0 times root 7, and root 7 times the sine of pi over 2 is 1. So it gives me 0, comma, root 7. Okay, so that's the converting from polar to rectangular. Let's move on to 6. Okay, number 6 is to convert from rectangular to polar, so that means I need to find what r is, and I need to find my theta. Okay, well, r, just like before, I'm going to use my Pythagorean theorem, so r is going to equal the square root of the square root of 3 squared plus the negative 1 squared and square root of 3 squared is 3 plus 1, square root of that, and that gives me 2. So r equals 2. Now I need to do my theta. So if I look at my graph real quickly, I know that this is in quadrant 4. And if I remember, tangent of theta is equal to negative, is my opposite over my hypotenuse. So tangent of theta is going to be negative root 3 over 3. And so what's theta? Well, I could write theta two ways. I could say theta is negative pi over 6, or I could use 11 pi over 6. Doesn't matter. I think I'm just going to use the negative pi over 6. And so if my polar coordinates are my radius, which is 2, comma, then my theta, negative pi over 6. Okay? And then there's number 6. So now the next three examples are going to be converting equations from both polar to rectangular, and then vice versa from rectangular to polar. Okay? So let's move on to 7. Now the thing about working with these equations and converting them is we need to remember a couple of things. Again, that x equals r cosine theta, y equals r sine theta, and the last one is that x squared plus y squared equals r squared, the equation for a circle. These are the three main things that we're going to be able to do or use. And it's really just going to involve substitution and then simplifying. So let's look at number 7. Number 7 says that r equals 11. Well, I really don't have anything that just has r by itself. It's got x's and cosines, so forth, but I have that r squared over there in that last equation. So if I square both sides of this, I get r squared equals 121. And I know, based upon what I had over here, that r squared equals x squared plus y squared. Or I could just substitute this in for r squared. Now I've taken that polar equation of r equal 11 and I've converted it now to rectangular. Let's do number 8. Alright. Same idea. But this time I'm going to convert a rectangular equation of negative 4x, sorry about that, negative 4x plus 13y equals 6. Alright. Well, I know x equals r cosine theta, and y equals r sine theta. Now the thing about polar coordinates or equations is we're trying to get r by itself, if we can. It doesn't always happen that way, but that's the goal. So if I look at this, I now have negative 4r cosine theta plus 13r sine theta equals 6. I can factor out an r from both equations. And what I'm left with is 4 cosine theta plus 13 sine theta equals 6. If I divide by the negative 4 cosine theta plus 13 sine theta on both sides, I'm going to get r equals 6 divided by negative 4 cosine theta plus 13 sine theta. My r is isolated, and so now I've converted that equation. And it's done. Once you get r by itself, you're pretty much done. Okay, let's look at number 9. R equals 2 over 1 plus sine theta. Well, the first thing I'm going to do is I'm going to get rid of that fraction. So I'm going to fraction bust it by multiplying both sides by 1 times 1 plus sine theta, and that gives me r times 1 plus sine theta equals 2. Distribute, and I get r plus r sine theta equals 2. Now your first instinct might be to change that r sine theta to a y. Just leave it where it's at right now. Okay? Just leave it alone. What I want to do is, I got to be able to get rid of both r's. So one thing I can try is let me move the r sine theta to the other side. And if you remember like what we did in the first one, number 7 here, with converting the equations, I could square both sides. And by squaring it, then I'm going to be able to get rid of that r squared. So if I square both sides, I get 2 minus r sine theta squared. Multiply that out, and you get r squared equals 4 minus 2r, excuse me, that's not a 2, it's supposed to be a 4. Plus r squared sine squared theta well, r squared by itself is x squared plus y squared equals 4 minus, well, that r sine theta right here, I can change that to a y. Now this r squared sine squared, I probably should have written it more like this. Those are equivalent. This and this are equivalent. Well, I know r sine theta is y squared, so I'm just going to put the y squared in there. And if I look at this, if I want to, I can move everything to one side, or I can leave the x squared by itself. That y squared's going to go away, and I'm going to get left with x squared equals 4 minus 4y. Okay? I could try to get y by itself, or I could just leave it like this. And so I'm just going to leave it like this. Alright, those are the examples for 9.6 on polar coordinates. Make sure if you have any questions, you come to class with them.